For this lesson, we're going to look at expressions and evaluating expressions, and we're also going to look at the basics of inequalities. So an expression just means that it has no equal sign. So it could be a single term like x or 2x, or it could be several terms being added or subtracted like 2x minus 5 or 2x plus 6y. Those are expressions as long as there is no equal sign. An inequality is when we have more than one possible answer. Is one way to think about an inequality. For example, if I say x, some number is greater than 1, there are lots of different numbers that could be greater than 1. 2, 3, 4, 5, and so on. There's tons of numbers, an infinite amount of numbers greater than 1. So we use an inequality when there could be more than one answer. And if you see something that tells you to evaluate, that is another word for solve. It just means to solve it. So before we look at our examples, I just want to refresh our memory on inequalities some more. Sign going this way is less than. This is greater than. We won't need these today for this lesson, but we will have less than or equal to. And greater than or equal to. And we'll get in those when we later in the unit we get into inequalities some more. Okay, so for this first set of directions, it says evaluate, so solve, each expression for the given values of the variables. So our expression is the 3x squared minus 10 divided by y. That's our expression. And then it tells us that x is going to be 3 and y is going to be 2. So we're evaluating, which means you're going to plug in those values for x and y, and then solve, making sure you follow order of operations. So if I do that, I'm going to plug in 3. When the 3 and the x are next to each other like that, it means times. So this really says 3 times x squared. But I'm going to replace x with 3. So instead of x, it's 3 squared minus 10 divided by, and then instead of y, I'm replacing y with 2. So everything stayed the same. I just replaced the x with the 3 and the y with the 2 like it told me. Now I'm going to use order of operations, and we can make a note on that. That is PEMDAS. So we're going to do parentheses, then exponents, multiply and divide come at the same time from left to right, and then add, subtract come from at the same time from left to right. So on this one, we have no parentheses. We do have exponents, so we'll do that next. 3 times 3 squared is 9, and then minus 10 divided by 2. So we did the exponents, now we're going to multiply and divide from left to right. So 3 times 9 is 27, minus 10 divided by 2 is 5. And then I just have to finish it up with subtraction. 27 minus 5 is 22. So our answer for that one is 22. Number 2, I'm going to replace both of the x's with 5 this time. So we have 3, and then in the parentheses, instead of x, I'm replacing x with the 5. So 5 plus 7, and then minus, and again there's another x, so it gets replaced with 5 again. And then again, order of operations. So we do have parentheses this time. So we're going to do parentheses first. 5 plus 7 is 12. Now, there are parentheses, however, there's nothing to do with the parentheses, so we can be done with parentheses. There's no exponents. We're going to multiply. When it's 3 outside the parentheses like this, it really means multiply. So this really means 3 times 12. And 3 times 12 is 36. And then we still have that minus 5. And then our last step to subtract, 36 minus 5, we get 31. And then our next one, we have two z's, so we're going to replace both z's again with our number it tells us is 10. So 10 squared minus 5, and remember when it's next to, that means times, so 5z means 5 times z, and again z is 10, plus 12. And then we're going to use order of operations. So we've got parentheses first, and inside our parentheses we have multiplying and plus. So we got to do order of operations all over again. So we'll have to multiply. So we're going to have 10 squared minus, and then inside the parentheses, order of operation. So multiply before we can add. So that's 50 plus 12. Now I still have parentheses I can do, so we're going to do that next. I'm just going to write up over here. So we got 10 squared minus, and then 50 plus 12 is 62. Again, technically, there's parentheses, but we could get rid of those because there's nothing else we can do in the parentheses, so we really could just get rid of those parentheses. We're done with parentheses. Exponent is next. 10 squared is 100. Still have that minus 62. And just like I said, we can get rid of the parentheses because there's nothing we can do inside there anymore. And then we can finish by subtraction. We have 100 minus 62. And that's going to give us 38 for this one. And the last one of these, number 4, 24 over x, and we're replacing x with 3. So we've got 24 over, which that fraction bar means division. Fraction bar is division. Only I'm replacing that x with the 3 that it told me. And then 24 over 3, which means 24 divided by 3 is 8. Okay, next set of directions. Compare each set of values using inequalities. So we're going to either put in a less than, an equal to, or a greater than symbol to finish off these statements. 3.15 is what compared to 3.7? When we're comparing numbers like this, make sure you're looking at the same place value. So this has a tens place and a hundreds place. In this one, it only has a tens place. So we have to add a 0 so that it has a hundreds place also. So we're comparing 3.15 compared to 3.70. So we're going to fill it in less than. If we think money, this is like $3.15 is less than $3.70. Number 6, we've got to be careful with negatives. If we remember on a number line, if I can picture a number line, I'm not going to draw the whole thing. Here's 0, and that's 1, 2, 3, and so on. And then negatives go the opposite direction. So negative 1, negative 2, negative 3, 4, negative 5, negative 6, negative 7. So as we're going left, the numbers look like they're going up. They're actually going down. They're getting smaller and smaller, but it looks like they're getting bigger. 4, 5, 6, 7, and so on. You're going down 4, 5, 6, 7. So negative 6 will be here. Negative 6.5 would be closer towards the 7 will be here. So the negative 6.5 would be here, negative 6 would be here. So because the negative 6.5 is further to the left, that means it is smaller. So the negative 6.5 is smaller. It's like losing $6.50 I have less money than if I only lost $6. Okay, and the last one, 4.3 compared to, this means 4.3 repeating. When that bar is over the top of it, it means that 3 repeats. So it's like 3, 3, 3, and 3 on forever. So if we compare this is just 4.3, it stops. So it's the same thing as 4.3, and I can say 0, 0, 0. If we think about it as money, that would be $4.30. If we think of this one as money, that'd be $4.33. So there should be less than. $4.30 is less than $4.33. So just be really careful with comparing decimals with the same place value to place value. You can always add zeros at the end. or more of the same number if it's repeating, like in that last one. And be careful that the negatives are going to kind of work backwards than what we would normally think.